Hey, Paul, I can't share slides while you're sharing slides.
You're a chair. You should be able to just yank my slide presentation. Right? But I'll
I
stop
agree with
sharing.
you.
I was just making sure that people could see it in the room when they would walk by before the meeting started.
Makes sense. Thank you. Thank you for
And you're
taking
you're a
that.
little bit soft in the room, so I'm not sure if you can bump your audio
I
volume.
can change my levels, yeah.
It's not just me, right? Or okay, I'm not sure if more is
Any better?
Yes. You can do a little bit more if you can.
Sure. How's that? Testing, testing. Hello, hello.
Could be a little more.
Okay. It looks like, yeah, it looks like Neat Echo is driving my volume back down. Fun, fun. If Neat Echo is going to do that, I don't know how to undo it in the meantime. So you might have to deal with me being a little bit quiet. I think we should be starting shortly. So I guess we'll give folks a minute or two. Just make sure who's here. All right, I think we should get started. This is the OpenPGP session. Thank you for being here. I'm Daniel Kahn-Gilmore. Your co-chair is Stephen Farrell, who I believe is on the way. Paul, thank you for sitting in the front of the room. Do we have a note taker for this event? Can I coax someone into being the note taker? Ah, I see a hand rising there.
Yeah, let me try and find the talkification tool.
Thank you. I believe that's Phil Hallam Baker is agreeing to be the note taker.
That is correct.
Great. Thank you, Phil. Much appreciated.
Oh, you've already put the agenda.
I think Neat Echo pre-populates the agenda into the note tool.
Oh.
As long as the agenda was actually in, yeah, as long as the agenda was in a markdown format. So this is OpenPGP. If you are looking for something other than OpenPGP, you should probably change to a different room. Let's see here. So this is the note well. It's Thursday. I assume that you've probably already seen this before, but these are recommendations about how to think about the information that you're sharing here. In particular, there's intellectual property rules. You've probably seen all of this. If you have not read it in detail, we encourage you to read it. We are a hybrid meeting. There are a bunch of us remote and some of us in person. Please make sure you're signed in if you're physically in the room. And even if you're physically in the room, join the queue using the little queue icon on your local tool. It looks like a little hand symbol, so that Stephen and I will manage the queue. If you are remote, keep your audio and video off unless you're chairing or presenting, and we encourage you to use a headset if you're remote. I want to remind folks about the code of conduct here. Please be courteous. If we have some disagreements here, but when we disagree with each other on the work. We're looking for the best solution for the internet, not just for one particular vendor or technology. Other than, of course, then the technology of OpenPGP, which is what we are working on trying to make better here. And so we're all pulling together towards the working group. This is the current agenda. We'll have a brief report back on interoperability and the status of the recently released RFC 9580 from Justus Winter. Then Falco will present the current status of the post-quantum crypto work. Daniel will present the persistent symmetric keys work, and Andrew will present the key replacement work. These are all chartered items. We are doing pretty well on all of them. I'm looking forward to hearing the report backs from the different presenters. If we manage to get through all of that, we have 90 minutes, now 85 minutes, 83 minutes. Andrew has a couple of other things that he wanted to present, so they're queued up as well. And if we manage to get through all that, then if folks have any other business, they can do that. If anyone wants to bash the agenda, now is the time to do that. But otherwise, I think we should probably just go ahead and welcome our first speaker, which is Justus. I'm going to stop sharing the slides. Justus, do you want to run your own slides?
No, I only have
Okay.
4 slides, and I'm happy to say next slide, please.
I will do
All
that.
right. I'm here to report on the test suite results and its state, and a bit on the deployment of RFC 9580. And I did a bit of experimentation, and in order not to compromise my main certificate and my ability to securely communicate, I created a new identity. You can see it on the screen. And below that is the RFC 9580 fingerprint of that identity. And if you click on that, you can download it. And you can also get the certificate using WKD. And unfortunately, for now, that's the only way to get that certificate, as we will see. And I must also say that while the identity is real, as in you can send mail there, and I invite you to do that, I haven't yet found an mail user agent that is able to decrypt the messages, but I will monitor it and I will try to reply. Next slide, please. So I'm very happy about the state of the test suite. I ported it to the next version of Sequoia, which is just boring maintenance. But I believe that it demonstrates very strong alignment between 5 implementations, PG Painless, RPGP, OpenPGP.js, and GOpenPGP, and Sequoia. And I believe this is a great result. There are 4 implementations that have released stable releases now with support for RFC 9580, which is very promising. And I also know that PG Painless is close, but needs a little bit more time. And as always, I would like to very much invite you to join the test suite fun. And the best thing to do is to, if you maintain or develop an OpenPGP implementation that isn't yet tested, to write a SOP implementation so that we can plug it in. And what also would be helpful is to suggest or write tests for the test suite. Next slide, please. So I created my identity for the RFC 9580 certificate, and then I got this certificate and tried to publish it and use it with various services. I started out with keys.oo, which wasn't happy with the certificate at all. Couldn't really do anything with that. You can see I have tried to publish it using the web interface of the service, if it had one, or via HKP, if that service was provided. And keys.oo doesn't yet do RFC 9580, so it rejected the certificate. Same happened with the mail-envelope key server. And then something interesting happened when I tried Hockey Puck, because it actually accepted my certificate and it replied with an interesting string. And when I re-uploaded it, I saw that it actually remembered the certificate. And the second time I uploaded it, it said, I updated the certificate that you provided, which was very interesting. And I was actually able to query it back by fingerprint, but not via the version 6 fingerprint, but via a pseudo version 4 fingerprint that you can see the prefix on the slides. And it replied with the certificate, but all the user IDs and subkeys were gone. So I only got the primary key packet and all the signatures. But it's interesting. I then tried to use Proton Mail, given that they maintain 2 implementations with support for RFC 9580. But I realized that product rollout is a thing. And it flat out refused the certificate. I also tried Delta Chat. And that was also promising because it uses RPGP, and RPGP has support for RFC 9580 for 2 versions. And glancing at the Delta Chat source code, I can see that it uses an up-to-date version of RPGP. However, I wasn't able to feed it the RFC 9580 certificate. Maybe that's because of autocrypt, which technically disallows version 6 certificate because of the shape. But I don't think that any autocrypt client actually verifies the shape as specified by autocrypt. Next slide, please. There is a silver lining though, because version 4 certificates can signal support for the second version of the CypD packet. And I did that with my main certificate now, and I haven't observed any adverse effects yet. And then I tried to see whether implementations see that signal and use it to upgrade to AAD and RFC 9580 style encrypted messages. Sadly, neither Proton Mail nor Delta Chat did that. But I was able to use Thunderbird using our PGP replacement backend called the Octopus. And my main mail user agent is not much, which uses gmime, gpgme, and if I use our replacement backend, I was able to have an CypD version 2 protected conversation with myself, which I think is a great step, and it gives you at least a little bit of what RFC 9580 brings you. So very briefly, this was very much ad hoc, and I did that last week. So if I got anything wrong, I would love to be proven wrong. I'm also interested whether we can repeat the experiment, maybe do it every few months and monitor the deployment of RFC 9580 that way. And I would very much like you to join that effort and improve what we did. And now I see Daniel. Go ahead, prove me wrong. I didn't mean to attack anyone or blame anyone for not having rolled it out yet.
Thanks for the implementation status report. I wasn't going to prove you wrong. I think it seems correct. I was just gonna say, since Proton Mail was mentioned, for our plans, the reason why we don't allow importing v6 keys yet is just because not all some users are still on old clients that don't have the latest version of our libraries that support 9580, and the same reason is the same. It's the same reason why we don't send SCIBD v2 quite yet, because then sent messages might not be decryptable by those old clients. But obviously, when all clients have been updated for a while, and especially for new users that have opted into v6 and PQC at some point, we can start allowing to import v6 keys, both for yourself and for your contacts, and then also send SCIPD v2. So we are actively working on it, but yeah, it's correct that we're not quite there yet.
Great, thank you. Andrew, you're on.
Hi, Eustace. Thanks very much for this. It's a great summary. Just from a hockey puck point of view, the results are not particularly surprising because currently the way that the hockey puck code base works is that if a key is not explicitly version 3, it is assumed to be version 4 in several places in the code. So the idea that it has a version 4 style fingerprint, even though it is actually a version 6 key, is not surprising at all. I am surprised that lookup works. It shouldn't, and that's something that I'll probably have to fix so that it doesn't cause any real confusion, because it might be possible to upload a version 6 key that collides with a version 4 fingerprint. It might be problematic. However, just for the future, I'm kicking off a project, hopefully in the next week or two, to start work on upgrading hockey puck to properly support v6 using HKP v1. I'll come back to that in my later presentation, and we're also looking into the same updates in KOO currently as well, and we hope to have them both working in the next few months at the latest. I will be doing the hockey puck implementation. I'm not sure who will be doing the KOO implementation at this time. Volunteers are always greatly appreciated. I do not want to write both sets of code for Firstly, because I'm not as good at Rust as I am at Go, so it doesn't make sense for me to write the Rust code. And secondly, I think having a diversity of implementations is really important, and I don't want to be the one writing both of them. And thirdly, I don't have the time. So please, if anybody wants to work on KOO, if you know Rust, please let me know, and we'll get you sorted out. Thanks very much.
Thanks for the perspective. All right, that concludes my part.
Thank you, Eustace. Next up is Falco. Falco, would you prefer I control the slides, or do you want to do them?
Yeah, I prefer I control them. Should I use Ask Slides or Ask Share Screen?
I think it's called Ask Slides for you.
Yeah, Ask Slides.
Yeah, and let me see if I can agree to that. How do I agree? Grant preloaded slides. You picked the right one. Thank you.
Yeah,
Falco.
thank you. Yeah, I want to report quickly on the status of the post-quantum draft. And first, we give an overview of the changes since last IETF. And we also, the first half is already, the first point is already included in the presentation we gave at the last interim. It's about the draft version 07. And here we assigned the code points for the signature algorithms. We aligned the key combiner with lamps. Also, in this course, dropped the CCA conversion from these ECDH camps, and we updated the security considerations accordingly. And we also switched to the hedged variant of SLH DSA, which is the default. I'll briefly come to that, to this change later in the slides. But then we've also continued work in the repository. This is the gray point for the version 08 to come. So we already designed the code points for the MLCAM plus ECDH encryption, and we further aligned the CAM combiner to lamps. So we are eliminating now the MLCAM public key and ciphertext. I'll come to that later, why we are doing this. And then we address two discussion points from the interim and the mailing list. One was about removing the hash binding for MLDSA plus DSA composites, because with a previous specification, we could not achieve CNSA 2.0 appliance. This was requested, so we are not binding any specific hash anymore to this algorithm. I want to remind that we are using always pre-hashing in OpenPGP. So that's the hash algorithm we're talking about. Then we are removing any statements regarding key selection strategy. So this was also a request, which we understood is reasonable. And we ask everyone who's interested in this to check if this is really now conforming to their preferences. Because there's still some statements, but they're not saying what to do, but kind of saying not to abort if you're doing the encryption to both a traditional and a PQC key. But that's not saying what you should do, but only that you're not to introduce, supposed to introduce any failure cases for this in your low-level implementation. Then here's a list of the code points that I just mentioned. We have the MLDSA plus add DSA. We have the 3 SLH DSA code points and the 2 ML chem code points still in gray because they're not yet in the published version. So now I come to the chem combiner, and first I give the combiner as LAMPS is currently specifying it. So it's inputting into the KDF the 2 shared secrets, and then the traditional ciphertext and the traditional public key, and then a domain separation string. The KDF can be either HKDF or SHA-3 256. And we are also using SHA-3 256 fixed, and we have the same 4 parts. And then the currently published draft, we also add the MLChem ciphertext and MLChem public key, but further analysis showed that we can drop this.
You have Scott in the queue there. I don't know if you want to take questions now or wait till the end, or.
Yeah, I will take. I thought I will take it. Just let me finish this description. And then we have the algorithm ID and domain separation. This is just conforming to equivalent to the domain separation LAMPS. Yeah. So please, Scott.
Scott Fleur, Cisco Systems. You mentioned CNSA 2.0 compliance. Well, they've published very explicit documents about what transforms are expected, and these are not it. If you take a look at Becker, CNSA 2, SSH profile, they spell out exactly what they insist on.
So our change is based on a specific request, which was about the use of SHA-3, which we prescribed, which is explicitly disallowed by CNSA 2, and this is what we addressed. So it's not
you explicitly have a hybrid chem operation, and they disallow that. They specifically say ML chem 1024 and nothing else.
Yeah, this is about the changes about signatures, not about ML chem.
They insist on ML DSA 87.
Yeah, we have it. So the point is that now you can have ML DSA 87 with whatever pre-hash algorithm you want to use. So this can be CNSA 2 conforming. You ignore the traditional part.
That's not what they are asking for. You should read their internet draft to say exactly what they want. And if you don't care about CNSA 2.0, that's fine. But if you want compatibility, you have to follow what they insist on.
Okay, we'll check that again. Thank you. So back to the chem combiner. So we're just aligning completely to LAMPS. Before these two, the MLChem ciphertext and the MLChem public key were considered part of the domain. So we were kind of aligned, but we now found that even this can be dropped without any security implications, and we'll give a justification. And that's then perfect, almost perfectly aligned to LAMPS. Of course, there are differences regarding the domain. This is a bit more explicit in our case, or different in our case, and we're not having the HKDF variant. So now just as a short recap of the last interim. So both proposals now also agree on not having a CCA conversion in the ECChem. And with this, both working groups believe that they achieve NIST compliance, or FIPS compliance. We're switching to the hatched variant for SLH DSA. This is just a natural thing because determining specifying the deterministic variant of SLH DSA was a leftover from the previous version, or the initial, the third round submission. And the hatched variant is the default, so it's not really even a useful decision to use the deterministic variant, and it also offers better side channel protection. And, yeah, Scott, please.
Corrections about the hedged version. It does not actually offer any side channel protection. Andreas misstated that when he wrote it up, and also, quite frankly, because they are completely interoperable, you don't actually have to make a determination about a requirement about which one.
Yeah, thank you. That's correct. You don't have to. In principle, you don't have to make a specification which one to use, but we think it's okay. We didn't really discuss this option, I think, among the authors. I personally think it's better to say this is the one to use, but we can still decide to leave it open. But there's probably going to be a problem for implementers to get even to access the deterministic variant, as the default is in FIPS is the hedged variant, and it will be more available. So should there be any concerns regarding this, please say it on the mailing list, then we can consider to leave this option open. But I think it's generally better to make a definitive specification here. Then a brief report to about the interoperability of 3 implementations: Go, Crypto, OpenPGP JS, and RNP. So for RNP, it's the version that we are developing. It's not completely integrated into the RNP main branch of the upstream project, but that's up to them, the timing and the decision what. So far they are they've been incorporating everything, but this is out of our control. So we have for all the algorithms, we have tests that are successful. So we are quite positive with this. Then about the ML DSA and ML-CAM private key format, there was a discussion. The current draft version 7 specifies the private key seed only format. In LAMS, the discussion surfaced that this might not be supported by all HSMs. Also, the PKC's 11 draft is not it is allowing both, is not formats, also the expanded format. So with our current choice, exporting a private key from an HSM and importing it to OpenPGP with the expectation that then you can use it, present it again, export it again in the OpenPGP wire format, might not be covered in all cases. So from this, there arose a discussion on the list, and I want to briefly summarize it. And what was there was a few mails, and I think we can summarize it quite almost completely here. So Stephen asked if we shouldn't wait for the LAMS decision, which I would say is there now. They will use both formats. How exactly is not necessarily clear. Yes, please, Philip.
Hi, back here. Yeah, I'm finding this business about the export from an HSM kind of strange. I mean, you know, HSMs are things that I don't normally export private keys from. And when I do, it's into another HSM using really proprietary protocols like Chrysalis Luna and whatever. So I can see how people might imagine that would come up, but I can't see where it would come up in practice. If you've got an HSM, the key stays in the HSM or the HSM manufacturer. works out how to squirt it somewhere else. So I wouldn't worry.
Yeah, thank you for this comment. I mean, this is mainly the comment that we'll come to that other people made on the list as well. But this was exactly why we had this question, where we had this discussion to determine the point of view here. I mean, generally, it's possible to have exports from HSMs. It's not that they don't offer it. Some do, some don't. And but let's start again. So about the lamps. First of all, lamps is now decided on using both formats, but they do so. I just want to explain here, because the PKCS11 is allowing expanded format, and then you run into the problem that this wide range of applications that LAMP has to cover might there might be coming up a case where you need this export, you need to generate a key from an HSM, you cannot export it to software. But Vincent Simon replied that this is not so relevant for OpenPGP because we don't have this wide range of applications. Then there was the point raised that we would prefer the expanded format due to the performance overhead of the seed format, but that's not really an argument, as Aaron concluded, because you can, in your private key format, you can have additional pre-computations and pre-computed expanded format. It's just that for the wire format, you need to retain the seed. But most people said, actually, a number of people said that this is not a use case, just as Philip now said, this is not a reasonable use case. And I just want to add, you will always be able to handle a case where you export the private key and then even import it into your software. It's just not, you cannot get back to the wire format, but still you can get it into software, and that should be sufficient for OpenPGP. I think this is what most people conclude in one way or another. So we plan to stick to the seed-only format for MLCAM and MLDSA. So then we plan to make the pending changes that I gave. This is about the CAM combiner. And then the pending changes that are going into the draft version 08. It's a number of them, assigning code points and the user, which are summarized on this slide. And then the further changes to the CAM combiner to further alignment to lamps. And after this, we think we are ready for working group last call, and we want to ask the working group if they see it the same way, if we should progress like this. I mean, it's not that we can go into it now because we still have to make those changes, but if there's some points that people see, I think it would be a good thing to discuss them now. That concludes my presentation. Yes, please, Quinn.
Quinn Dang at NIST. With the presentation I have just seen, on technical ground, they all look good to me. Yep. And also one thing, it's just not really my concern, but I just wanted to put it out there. Hopefully it's useful for some others. If you do care about NSA 2.0 suite, then it would be best you talk to them to make sure whatever solutions you have right now would be welcome or accepted by them. If I were a business provider who providing the services or whatever for their use, I don't want to like guessing, you know, what they will accept or not. But it's not my concern. But hopefully, just to help the vendors there do the right things for themselves.
Thank you.
To reiterate, if you care about CNSA 2.0 compliance, they've already documented in an internet draft exactly what they're looking for. You don't need to guess or ask them. They've told us.
Okay. Yeah. Thank you again.
Okay, if no one else is in the queue, Eustace?
I just wanted to say that I support going to working group last call. Seems fine. I mean, we can polish it over and over again, right? But it seems like we arrived at a reasonable point, and people will always be unhappy with that. Let's do it.
Thank you.
Okay, thank you, Falco. If you can release the slides, I will bring up the next. Daniel, you should be up next. Do you want me to run the slides for you?
Is there a clicker or no?
There is a clicker.
And I can do it. Okay.
Paul, is that something you can set up, or do you need me to do it?
I guess.
I can do it too.
How do I hand it over to the clicker?
So the clicker is a person in a room, just like anybody else, and you
So I
just
just
give
did
it.
that?
You
Steven
just
did
give
it.
it the presentation rights like normal.
Let's see. Does it work?
Should, yeah.
Seems to work. Yes. Amazing. Thank you. All right. Yes. So I'm going to be presenting about persistence metric keys in OpenPGP. And I thought I would start with a short recap for those in the room or remote that are not regularly joining the OpenPGP meeting or didn't join the last interim, for example. So yeah, just a very short summary of what this is about. Historically, in an OpenPGP transferable secret key or transferable public key, you can only store asymmetric key material, which makes sense, of course, when you're using it to communicate with other people. But it turns out that it's quite common to encrypt and or sign stuff with your own key as well. For example, when you're encrypting a draft or a send message, or for your archive, for your backup, and so on. And in that case, using asymmetric cryptography is overkill. And especially with the transition to post-quantum cryptography that we're doing, we wanted to introduce the option of doing something more efficient. So basically, the proposal here is to be able to store long-term symmetric keys in transferable secret keys, so that you can encrypt and or sign, meaning authenticate messages using your long-term persistent symmetric key. And to accommodate that, we propose to rename the public key algorithm registry to the persistent key algorithm registry, and also rename some of the packets to match. But the semantics of all the packets remain the same. So yeah, here's the concrete proposal, the overview of the algorithms. So we propose an AAD algorithm with the same AAD algorithms that are already being used in SCI/PD v2, and HMAC to quote unquote symmetrically sign or authenticate messages. And then we reserve a number of algorithm IDs for future symmetric algorithms. This is the only very minor change since the interim in this table, is that the range of private or experimental persistent symmetric key algorithms has slightly changed, and they have been condensed as well, because probably we don't need so many. And also the range of persistent symmetric key algorithms is now a little bit more binary friendly, in the sense that all of these algorithms start with 1000 in binary. And so yeah, it should in theory make it very simple to check whether a given algorithm is symmetric or not in the cases where that's relevant. Other than that, nothing has changed since my last presentation. Then one new topic I wanted to bring up is about which key flags should we use for these key packets. We currently have 3 that would seem relevant, namely a key can sign data, it can encrypt communications, or it can encrypt storage, or both of those last ones. And so far, typically all keys have always, all encryption keys have always had both of those, and implementations typically haven't made any meaningful distinction between encrypting communications and encrypting storage. But here we might finally find a case where the distinction might matter. And for signing, the distinction might matter even more, because if you're creating a signature packet, it suddenly becomes very important to know whether you're going to send that signature to other people, in which case obviously it needs to be an asymmetric signature, or whether you're just going to store it for yourself, in which case it can be a symmetric signature, or just an authentication. So here I thought it might make sense to introduce a new key usage flag that we could call sign storage, for example. I mean, naming up for debate, but for symmetry with encrypt storage, we could have sign storage and then rename sign data to sign communications, and then say that all symmetric keys should have the key flags for storage, and asymmetric keys should have the key flag for communication if there is also a asymmetric key. Otherwise, if you're only generating an asymmetric key, then you can still give them both encryption flags, at least, same as we do today, basically. And then when you're encrypting and or signing a message, you could say to your OpenPGP API, hey, this message is intended for communication, so please use the communication keys. Or you can say, this message is only for storage, so please use the storage keys. Or you might have a message that's intended for both, or is somehow a mix. Like you might encrypt and or sign an email that you're both going to send to other people, and also store for yourself in your send mail or whatever. And if you do that as a single operation, then you should use the asymmetric keys to sign, meaning the communication keys to sign. But for encryption, you can use whichever is available, and you might actually prefer the symmetric key if you have one, since it's more efficient. So yeah, that is roughly the concrete proposal there. Then there are some thoughts about, if we go back to this table, is the first row even necessary if we have the last one? Because basically the only difference is that we disallow the use of symmetric keys, or storage keys for encryption. Otherwise, those two rows are the same, right? So you might ask, well, when might you not want to use a symmetric key? And we did think of one case, although it's quite an esoteric edge case. But if you're sending an email to yourself, and you have set up an automatic forwarding using Aaron's proxy re-encryption automatic forwarding draft, meaning you have an ECDH key and it gets automatically transformed and forwarded to another email address, then you want to encrypt the message using that asymmetric ECDH key when sending the message to yourself, even though you might also have a symmetric key. But again, it's a very specific edge case, and you could also solve that by just taking the transferable public key corresponding to the transferable secret key, which will not have the secret symmetric key material in it, and then the OpenPGP implementation should automatically use the asymmetric encryption. But contrary to that, we might, in some APIs, want to be a little bit more conservative and want an explicit signal to allow using a symmetric key. This is, for example, today explicitly written in the SOP API that you cannot pass a secret key in order to encrypt. You need to pass the public key. And if we want to stay with that behavior, we might want to pick the first option, the first row here, as sort of the default behavior, and then require one of the others to be opted into explicitly in order to use a symmetric key. But in most other cases, especially in APIs that already allow encrypting using a private key, today you might just default to the mixed option in this table, in my opinion. But this is all up for debate and perhaps up to the individual implementers. Yes.
Daniel, you have a cue here.
Yes.
I wanted to just say, with no hats on, just as an implementer, I'm not convinced that the juice is worth the squeeze for the this communications storage division that you've described. I could maybe be convinced, but it might help to not tie it to the words that are already very difficult to understand and probably pointless. The existing communication storage split for encryption has not been used, and most implementations don't use it on encryption. So perhaps if there is a distinction, and also if you were to try to make that distinction, it doesn't necessarily about whether there's someone else on the receiving end versus myself. It could also be, for example, to do with the duration that the encryption needs to last, right? Communications only needs to last until the recipient receives it, whereas storage needs to last indefinitely. And those are different things than whether it's for somebody else versus for me. So if you want to make a distinction here for signing, or you want to add an actual distinction for encryption, it might be worth thinking through how to make that distinction without using the terms communication and storage. Anyway, I'm going to let the next queue go.
How are these keys being used? I mean, like, I really don't like encrypting more than one block of data, well, more than one chunk of data under a specific key, particularly with fragile constructions like GCM and so on. If we're going to, is there a KDF in there? You know, it's good to use a different key each time you encrypt. And so rather than looking at these as keys, I'd prefer to look at them as key sources, but you didn't seem to address that.
Yes, there is a KDF in there, and also the thing that we're encrypting here are in-turn session keys. So we still keep the. So normally in OpenPGP you have a hybrid construction, right, where you symmetrically encrypt using a session key, and then you asymmetrically encrypt the session key, and we keep that. Those two steps here, even though both steps will be symmetric, you still encrypt the data using a session key, and then you encrypt the session key using your using a key derived from the persistent symmetric key. So this is just to make it more consistent and fit within the OpenPGP framework, let's say. Andrew.
I don't know, just really quickly. If we're distinguishing between two types of signing keys, what are the circumstances under which you would invalidate a signature based on using the wrong key flag?
So the main goal for me here is not to invalidate a signature, but rather to be able to indicate which key to use. So if you have both a symmetric signing key and an asymmetric signing key, then I want to be able to say, well, this message I'm going to send to someone else, so I want to use my asymmetric key, meaning my my communications key, right? And then, like, when you're verifying a signature, if the signature packet is made by the correct key packet, then I don't think you necessarily have to look at I don't think you have to think about it as a verifier that much.
Okay, no, my point kind of is, if you are not going to invalidate a signature based on this information, then it doesn't need to be published. It doesn't need to go into the TPK, and maybe it should just be an API parameter.
Yeah, it could be as well. I mean, it could be a parameter that says, do you want to use an asymmetric key or a symmetric key, right? Which is basically the same thing as what we're saying here. It's just that since the key flags exist and they seem to map well to the semantics that we want. I think like there is another benefit in my mind to, for example, not putting the sign data key usage flag on a symmetric signing key, which is that you're less likely to accidentally use it when you don't want to, right? So that's kind of the thought behind then putting a different key flag instead, if it makes sense.
I'm skeptical, but I will yield the floor.
Okay, just very quickly, we do explicitly support the distinction between encryption and storage, communications and storage encryption. We know that it's not used much, the distinction, but we need to start somewhere, so we did. I do support the distinction between the signing use cases, and I think key flags are a fine place for that, because that's an interoperable way to signal intent as a key owner, and the implementations that use the key can act accordingly. Okay, thanks.
So Daniel, just a time check. I think we're kind of out of time for this slot, I guess. But so can you speed up a little bit? That would be great. Thank
Yes, I will do my best. Thank you. All right. So I wanted to briefly mention some suggestions for how you might use these algorithms in a larger key structure. So this is one, basically assuming that people are going to generate a separate V6 and a V4 transferable secret key, one for PQC and one for ECDH. I mean, or ECC. This is obviously the details are. This is just an example. It doesn't have to be exactly like this. And then with this draft, you could create an additional transferable secret key for the symmetric algorithms. And then when you would derive the transferable public key from this, like the thing that you're going to send to other people, will be just the transferable public key for the asymmetric keys. So the first two, you would just drop them. Or if you don't care about the symmetric signing use case and you only care about the symmetric encryption, you could only add a subkey instead, although then the downside of this is that even when you just want to symmetrically encrypt, you still need to verify an asymmetric PQC signature. So you're making things slightly more expensive, but perhaps that's manageable. Then, yeah, I had quite a lot of slides about API considerations, but I will just maybe briefly mention that there are a bunch of issues in SOP, kind of considering how SOP could be adopted to allow the usage of persistent symmetric keys. So yeah, I won't go through all of them in the interest of time, but here the links are in the slides. Please take a look at whether this proposal makes sense, and then yeah, can discuss there. Then questions for the working group. Well, we have already discussed it a bit, and yeah, thanks for the feedback so far. So, but if you have more feedback on whether the proposal about key flags makes sense, I can also bring it to the list, or yeah, we can discuss more there. Another question is whether we need to have some guidance on the key structure in the draft, or whether this can, you know, stay fully separate. And also, this is like the 10th place that's kind of adjacent to key selection. So if we're gonna affect, you know, how keys should be selected here, perhaps we should, you know, start actually tackling the discussion of how to do key selection in general. So perhaps we could start discussing that as well, either on the list or perhaps at the OpenPGP email summit. So yeah, that's all I have. So thanks a lot. Let me know if you have any questions.
So, Andrew, I think it's you up.
Yes.
You should be receiving slide control.
Oh, thank you. I've just got it. Okay. So I have 3 decks here. This first one is the only one that really needs to be done today. The other 2 are as time permits. So this one, thankfully, is very short. So I will get straight to it. If you were at the interim meeting, you will already be familiar with the contents of this because I presented all the slides here there, but I have cut out a lot of them. So I've left in essentially one meaty slide. Oh, sorry, I clicked there too fast. So the basic design of the replacement key subpacket, it's a signature subpacket for use in direct self-signatures and key revocations, which indicates to your third parties that you have ruled your key and you would prefer them to use another TPK. The rest of the slide has not changed from the last 2 times that I presented this, so I will not go through it again. If you have any questions, please let me know. But essentially, it provides a form of binding between 2 distinct certificates or TPKs. Recent changes since the last interim, there was a slight change made to clarify how a thieving implementation should parse an overlong target record. That was introduced just in case we want to add extra fields to the target record in the future, but it does not currently define any extension scheme for that. It just clarifies that the length octet at the beginning of the target record is definitive, and if the target record appears to be too long, just ignore the extra bytes. And that should be sufficient if it is followed to make the packet forward compatible if we wish to introduce extra fields at any time in the future. Otherwise, I just decrofted a little bit of recommendations that weren't strictly necessary. Thanks, Justus, for the tip. The only outstanding item, therefore, is this decision, which we left unresolved at the interim meeting, is how do we deal with fallback? Do we want to allow the key owner to recommend a particular fallback strategy whenever there is an equivalence binding in place? The current status, which is the default, which is the option 0 that is here, is fallback from a replacement key to an original key is always possible if the correspondent supports it. There is an open merge request based on a request from Johannes about making this configurable per target. And this is why the target change, or it's one of the reasons that motivated the target record change in the previous slide. And there are various other options if we do not choose either 0 or 1. Now, we took a quick straw poll at the last meeting, and it was inconclusive. Since the last interim meeting, there have been a couple of emails on the list expressing a preference for option 0. So at this point, I am leaning towards option 0, which is to leave as is, unless there is unless anybody has any specific reason why we should not proceed with option 0, I'm minded to proceed with option 0. So at this point, if you do know of any reason, please speak. add yourself to the queue. Okay, so if nobody wants to speak now, I will relay this to the list, and we may make a final decision soon, I hope. So I was hoping that we would be able to issue a final draft with this outstanding issue addressed, and so, like I say, I will mention this on the list. Once that is done, I believe that this is ready for working group last call. And so, thanks, Stephen.
So Andrew, just a timing question. If we have the post-quantum stuff and this both roughly ready for last call at the same time, would it be sensible to do the post-quantum stuff first and then this?
I have no particular preference. Like, I do think that post-quantum needs to be finalized soon, and that's also. Yeah. There's obviously a lot of work that has gone into that, and I think it's at a much more advanced implementation stage. So even though this is not as difficult to implement overall, I don't believe it is as advanced in implementations as post-quantum. So it would make sense to do post-quantum first.
Okay, so we might sequence it that way if that's where sure. Thanks.
Yeah, problem. And that is it. The links are here, and if you want to raise any issues, or if you have a strong objection to proceeding with option 0, please take it to the list. Thanks. Next deck, please. If you have a choice of which deck to do next, I'd prefer to do HKP first, if you don't mind, if that's possible to order it that way.
We can do that. You're driving the current deck. So
do I need?
Let's see.
Okay.
There's HKP, and then I want to give it to you. How do I give it to you? There you go.
You
got it.
Thank you very much. So, a quick update on the progress of HKP. There hasn't been that much movement in the draft itself since I last presented it, which would have been 18 months ago, I think, at this stage. But I will run through it very quickly. Sorry, the deck is, there's a lag in the clicks. So the basic idea behind the HKP draft is that we will take the existing draft from way back in 2003 that everybody knows and loves, and we maintain that as a legacy format. And then on top of that, we have a versioned machine readable only API. And this machine readable only API has type safe getters. So instead of there being an unstructured search field, we have specific operations that accept more tightly structured request data. So there's only one way to get to search via fingerprint. There's only one way to search via key ID. There's only one way to search via email or user ID. Also, we have unfolded the rather nasty search query parameters and turned them into static fields in the path. And the nice thing about this is it allows us to serve keys simply using static files, which is one of the big advantages of WKD, which is the ability to search to just serve static files. This then allows us to reuse HKP as a key discovery method using a policy file that would sit beside or instead of the WKD policy file under .well-known. And the reason we want to do this is so that we can safely implement a WKD-like discovery protocol for version 6 keys without confusing or messing with legacy clients or alternative specifications. The other thing that is in is a specific declaration of how to handle detached revocations. I've specified this mixed keyring, and the idea behind the mixed keyring is that detached revocations appear first, so they cannot be confused with signatures over another object. This hopefully makes the versioned API a lot more stable and a lot more tractable than the legacy. Since the last draft, which is draft 6, I've literally just published draft 7, but you may not have a time to read it. We've added a couple of extra additions to support the keys.pgp.org use case, and these specifically are the idea of confidence, which represents the verification state of user ID if the key server itself is confident in the status of a particular user ID in a certificate, it can say so. And then we have a corresponding lookup method called authget, which is the authoritative get operation, which will only return high confidence results. This is required for key discovery, where we assume that a certificate returned by a key discovery method is in some way authoritative. And also for keys.openpgp.org, which has been working on the same principle for several years now and wishes to continue to do so. The other novel thing is a since operation, and this will produce a prefix log. There was an earlier attempt at this by DKG and Vincent Breitmoser, and I've spoken to Vincent about this recently, and we hope to include this in updates to KOO at some point in the near future. And this is a backport of that idea into HKP, so that HKP is feature compatible. Basically, it's essentially a Bloom filter. It's a kind of poor man's Bloom filter. Stuff that is still not in, but probably should be, is some form of authentication. We haven't decided yet. I've been speaking to the KOO board about this. We haven't nailed down a specific method. One idea is that you make a request to a particular URL endpoint that will send you an authentication token by email, and then that might be used then as an authentication token to edit or update a certificate. Or there's another method that we could try, which uses an out-of-band method that relies on DKIM signing email messages to yourself. That document is now in the repo. I will bring this up on the list for anybody who wants to take a closer look at it. And we also had this idea before about being able to do recursive lookups like DNS. That might not be necessary. So the next steps that we would like to do with HKP is, like I said, to finalize work on these authentication methods, and then perhaps we could reopen the call for adoption. But I would hope to be able to do that in the next little while. Not quite yet, but soon. And these are the links, the draft, the latest draft, the repo, and this discussion document about out-of-band verification, which we can discuss on the list. I won't get into it now for reasons of time. Any questions or concerns about this?
So I think there was one comment from Justice in the chat. I don't know if you've seen that.
I don't.
If you want to address it.
Okay. Where is it?
Oh, was that Justice? Was that on this talk or?
Yeah, I was unclear about what a detached revocation is.
Detached revocation is the. Sorry, I've lost my screen. Detached revocation is the old version 4 style revocation signature packet that is distributed just by itself, unlike the version 6 revocation, which is distributed with the primary key packet.
Right. Please don't do
Because
that. And for the record, that's not a V4, V6 thing. You can perfectly fine have a V4 primary key with the revocation, and it's so much easier and so much more robust to communicate and consume. Thanks.
Yes, it's not, unfortunately, it is not always accepted by legacy clients. And this is purely there for legacy client support. It's not something that we recommend using into the future. As you say, it's strictly RFC 9580 compliant. But unfortunately, there are clients out there that do not accept V4 revocation signatures without a user ID, etc., etc. This is a long-running pain point, unfortunately.
Well, you can, if you're worried about that, you can distribute the user IDs as well. Anyway, let's take it offline, and I would like to see concrete points on legacy clients that don't accept the revocations.
Sure.
If this is about an HKP version 2 with the version 2 API for distribution, then maybe the legacy clients don't matter. That's the other advantage we have, right? If you upgrade your tool to use HKP version 2, then you should be able to accept the full-blown revocation cert.
Yes, and we can specify that in the version API that this is not done, but we also specify the legacy API in which we may have to support it. Like I say, I'm not happy about it. There have been several inconclusive discussions on various mailing lists about it over the last couple of years. So we may have to live with it, unfortunately. So I will Sorry, Stephen.
No, just is this the right slide deck for you?
Yes. This is.
And just to note, we're down to 8 minutes.
Yes, I will rattle through these really quickly. This is purely a FYI slide deck. There are a lot of slides here, and I will not dwell on them. But I've been well aware over the last little while that there are a lot of niggling pain points within OpenPGP, which are rooted in the lack of very tightly defined semantics and the historical thing going back to the very beginning of PGP. Excuse me. There are currently 3 internet drafts that I'm involved in various ways that are published and are available for your reading pleasure. And I will go through them very quickly to explain why they exist, what they do not do, and how they relate to each other. They are draft DKG OpenPGP revocation. This specifies a wire format change to replace the deprecated revocation key feature, which was deprecated in 9580, but not explicitly replaced with another mechanism. And there are also various semantic changes to tidy up how revocations are handled or should be handled, and when they should be made, and so on. As a companion piece to that, then I wrote draft Gallagher OpenPGP signatures, which covers non-revocation signatures and also signed message formats. In particular, the treatment of OPS packets into OPS nesting, which are hairy parts of the spec. There are no wire changes in this document, and I hope not to introduce any wire format changes in that document. It is purely a semantic document. It deprecates several constructions that are confusing or poorly supported, and it tidies up some interpretations and semantics around that. However, some of these changes may be slightly controversial. and you are free to disagree with my particular suggestions. But I do think that having this document is useful as a starting point. And then finally, most recently, based on the fact that there were things that could not be done in either draft revocation or draft signatures without new wire formats, I specified some new wire formats, which I hope will cover the bits that cannot be reasonably implemented by just semantic changes. So in revocation, we have this delegated revoker method. There's one method that is in the current draft. The current draft has not actually been published. It's in approval hell at the moment, but you can see it on the editor's copy, which is available. The links are in at the end of these slides. And there is a merge request to possibly replace this with a slightly different construction. There are trade-offs involved with both of those around backwards compatibility with legacy clients, which we'll probably need to put that into the interim tests to really nail down. And then these are the semantic changes that are made in OpenPGP revocation. I won't go through these. You can see them in the document itself. The signatures and signed message draft is the biggest one, but I think it's fairly systematic in that it just has a list of recommendations that are relatively independent of each other. One of the things that it does is it imposes some order on signatures and signature types and signature subpacket types, because at the moment it's a bit of a zoo. You can mix and match things with free abandon, and not all combinations are necessarily meaningful. And so I have attempted to constrain them to meaningful combinatorics. There is an embeddable signature type, and that is used specifically to avoid depth recursion, where signatures can be embedded inside other signatures to infinity by dividing the signature types into embeddable and non-embeddable types, and not allowing one to embed the other. Basically, you cannot embed them to infinity. It also assigns a private and experimental signature type range, which did not exist before, and it rationalizes the treatment of the various certifications. This is something that has been knocking around for a while in various formats, particularly DKG has mentioned it in a few places. I've tried to put that in a formal recommendation. Some of the controversial bits here might be all of these unused and imprecise features, which I don't believe anybody really has a use for, and therefore just complicate the spec. The formal message grammar is slightly constrained beyond where it is. Again, this is to address nesting issues and just mostly nesting issues to do with compressed data packets and so on. And then it specifies an actual a concrete construction for timestamp signatures if anybody wants to use them. They are currently the code point is reserved for them, but it doesn't actually say how to make one or how it should be used. It also specifies what you should do with third-party confirmation signatures. It recommends the hash packet area must always be used with a very small number of exceptions. And this is the one that I expect to generate the most noise, is a change in the temporal validity ambiguity of binding signatures. We have some long-running argument about when binding signatures are valid from, and this specifies that binding signatures are valid from the subkey creation date. This has quite deep changes, but I believe that they're useful changes. And just being aware of time, the third document, which is the OpenPGP attributes document, does three really major things. The first thing is we deprecate image attributes because at this point they are purely an abuse vector. And no key server currently serves them. Hockey Puck and KOO definitely have not served them for. KOO has never done it, and Hockey Puck hasn't done it for about 18 months now. And as a replacement method, we define some other attribute subpackets which can be used to fill a few missing features in OpenPGP that are currently not possible. One of those is the distribution of revocation signatures over a third-party certificate, because at the moment there is no way to reliably distribute that if the third party is not cooperative, and this allows you to distribute them on your own key safely. And that is the end of that. Thank you very much, everybody. Please take discussion to the list. Links are here, and I'm sorry for using up the remainder of the time.
No problem, and thanks for presenting. Justice, I think, did you say you had something you wanted to bring up just at the end?
As I
mean, I just wanted to mention the idea I had.
As I read it, that's something that we can take to the list or to the GitLab trackers that are there. We are at time.
Right.
Thanks everyone for bringing the work, and please follow up on the list. Andrew, I don't see a formal call for adoption for any of these drafts that you just talked about here, but sorry, I didn't hear you.
Sorry, no, I not made a formal call for adoption for this new work. No, not yet.
Okay, but thank you for raising the attention of it for the group. Hopefully, if folks can take a look at those and think about whether you think they might be worth adopting, we can talk about that more on list. I think Stephen and I will look into whether we want to schedule another interim before the next meeting, and hope y'all have a good rest of the IETF week.
Great, thanks.
Stephen, any last words?
Big late, and thanks to our note takers. Phil, I think that was you whose head I can just see on the screen now. So, thank you.
Thanks very much, guys.
Thank you. Bye-bye. Tomorrow. We saved the best for last.